In this video, we are going to be completing the problems from the practice exam 2. The first 6 are the 13-14 questions, which will count towards your 13-14 grade. The first section, problems 1 and 2, says solve the absolute value equations. It's an equation, which we're talking about equal signs, not less than whiches, not greators. That's not until the next section. These are just equals. So before I do any absolute value problems, I first need to make sure that the bars are all by themselves. And it looks like it. There's nothing being added or subtracted outside the bars, so that's good. Step 2, is this 13 positive? Yeah, it is positive. So now I can proceed with the rule. The rule says for equations, we need to break it up into two equations. Either the inside of the bars, 5x plus 3, can either equal negative 13, or the inside 5x plus 3 could equal positive 13. The reason is because the inside, the 5x plus 3, if that turned out to be positive 13, then the absolute value of positive 13 is still 13. Yay, it works. If the inside 5x plus 3 turns out to be negative 13, well, then the absolute value of negative 13 is still 13, and it still works. So at this point, all we need to do is solve. So the first one, I'm getting negative 16/5, and it doesn't really matter which order you put them in, one on the left or one on the right, it doesn't matter. Whatever makes you happy. Okay, so I'm getting x is equal to 2 and x is equal to negative 16/5. Those are two distinct answers. They're not an it's not an interval of answers, so it's just two answers. You could leave it x equals if you want, or you could put it in the solution braces. Either of those two ways is correct. Now on number 2, notice that the bars are not all by themselves. We've got this plus 9 out here, and we've got to multiply by 2 in front. So we need to fix that up first before we can identify if the right-hand side is positive or negative. So I know the 7 looks like, oh, it's positive, it's going to work, but we don't know yet because we have to solve for the bars. So we have 2 times the bars equals, I minus 9 from both sides, and I get negative 2. Now I'm going to divide both sides by 2, which gets me the bars, absolute value of 6x plus 5 is equal to negative 1. Notice I had to do all that work just so I could look like the first step of problem number 1. Okay, so now it looks like the first step of problem number 1, where the bars are by themselves. That was step 1. So step 2 says, is this positive, the number on the right-hand side? And the answer is no, it's not positive. So because this is negative, the absolute value of any number can't be negative 1. It just doesn't work. So therefore, the answer is no solution. Without any more work to be done, you can't have the absolute value ever equaling a negative number. The next section says to solve the absolute value inequalities. Express your answer in interval notation if possible, and then graph. I actually like to graph first and then put it in interval notation. Step 1. Are these bars all by themselves? Yep, they are. There's nothing being added or subtracted or multiplied in front, so they're good. Step 2. Is 4 positive? Yep, 4 is positive. Okay. Now I have to decide what kind of problem this is. Because it's the absolute value is less than or equal to 4, I know that this is a less than which means x minus 9 is going to be sandwiched between two numbers. The numbers are going to be positive 4 on the right and negative 4 on the left. And that's the rule for less than which. Now I'm going to solve for x, and x should always be in the middle in this class. And I get the inequality 5 is less than or equal to x, which is less than or equal to 13. Now I'm going to jump down here and graph it. So I need to put a 5 and a 13 on there. 5 and 13 both have closed circles because it's or equal to. And then because x is sandwiched between, I draw the line between. Now that I see my graph, I can get my interval notation really easily. 5 to 13, both brackets. On number 4, the bars, step 1, the bars are not by themselves. So I need to get them by themselves by subtracting the 5. Then I have bars are greater than, and 14 minus 5 is 9. Excellent. So, step 2. Now that the bars are by themselves, is 9 positive? Yep, 9 is positive, so we're good. And what kind of problem is this? Is this a less than which or a greater? Well, because it has a greater than symbol, it's going to be a greater, which reminds me that I need to have an or. So I'm going to have the 2x plus 1 in both of my equations. Okay. The way I remember this is one of the equations looks exactly the same as the original, just without bars. So 2x plus 1 is greater than 9. I like to put that on the right. On the left side, we have two sign changes. The inequality of greater than switches to less than, and the sign of the 9 changes to negative. And now I can solve those two. That gives me x is less than negative 5. Subtract 1, I'm getting 2x is greater than 8, and then I have 2x is greater than 4. I'm sorry, x is greater than 4. So those are my two answers in inequality notation, but that's not what I asked for. I asked for interval notation. So I am going to graph first because I find that to be very helpful. I have a I have a negative 5 and a positive 4. Okay. Both of those do not have an or equal to, so they have open circles. The first one says x is less than negative 5. Less than is to the left because it starts with L. X is greater than 4, so that reminds me it's a bit to the right because it's greater to the right. Now that I can see that picture, I have two lines. So because I have two lines, I have two intervals. My first interval starts at negative infinity and stops at negative 5. I have a parenthesis on 5 because I cannot reach 5. It's not or equal to, so it's a parenthesis. Union, that means I have a gap there. Union 4 till infinity, again with parentheses for the same reason. And that completes that problem. For number 5, we have the absolute value bars all by themselves for step 1, which is good. Step 2, you're asking, is this positive? Okay, and the answer is no. The C is negative. So because C is negative, this cannot be a less than which or a greater. This is neither of those. This is a special case. So the answer is either going to be all real solutions or no real solution. So how do I write that? So let's see. I don't know which one is which. I'm going to have to really figure out, is it going to be no solution or infinitely many solutions? So let's think. We have the absolute value bars. What do the absolute value bars mean? It means whatever's inside is going to be positive, or technically 0. So positive or 0 things are always going to come out of that left side. And I know that that's greater than negative 6. So are positive things always greater than negative 6? Or never greater than negative 6? Well, this is always true. Now, always true isn't the answer, okay? What is the answer? Well, the answer is all reals. And the way we write that in interval notation is negative infinity to positive infinity. The way we graph it is just a line which shows you every single answer in the world. So if it's ever greater than a negative, the answer is all reals. For the last problem on this page, we're going to subtract 5 on both sides. So the bars are by themselves. We need the bars all by themselves first. So we have x plus 2 is less than negative 2. 3 minus 5 is negative 2. So step 1 is done. My bars are by themselves. The next question is this positive? If it's positive, then I can keep on going with less than which or greater, but it's not, okay? In this case, C is negative. which means this cannot be a less than, which it cannot be a greater, it's a special case. So which special case is it? Well, I have to figure that out. I know that whenever I take the absolute value, I'm getting something positive or 0. So my question is positive things always less than -2 or never less than -2? In this case, it's never true. So what does never true mean? Like, there's no number ever that I can plug in here that's going to get me less than -2. So there is no solution. You could also put that symbol, that's another symbol for no solution, or just write out no solution. What would you put on the graph? Well, you would put nothing on the graph. If you put anything on the graph, that would imply that you thought there was an answer there. But because there isn't an answer, I want you to leave it blank. That's the only part of the test that you can leave blank and get correct, okay? Usually, if you leave any part blank, that means it's wrong. But in this case, it has to be blank because there is no solution.